Hi, I'm Thomas, and this is a motor. Step 1. Collect all the ingredients. For this motor, I used shielded copper wire, a nail file, electrical tape, a 9-volt battery, neodymium magnets, safety pins, a marker, and a Tupperware. Step 2. Cut half a meter of wire. Then, make a coil by wrapping the copper wire around your marker. Make sure the wire is wrapped very tightly around the marker. Leave some room on each end of the coil. Then, loop both ends of your wire around the coil and pull it taut. At the end, it should look like this. My coil had about 5 turns, but more works as well. Step 3. Sand the wire. Ideally, you would use sandpaper, but I just had a nail file. This step can take a long time, so be patient. Step 4. Tape the magnet to the bottom of the Tupperware. You may need to mount it on something to move it closer to the coil. Step 5. Tape the safety pins to each side of the Tupperware. The ends of the battery will go at the bottom, and the copper wire will sit on the holes at the top. Step 6. Connect the battery and watch your motor spin. If you have done everything right, the motor should be working. If not, check to see if the wire needs more sanding or if the coil isn't symmetrical. Here is a video of my motor. Now, you may be wondering, how does the motor actually work? Firstly, the magnets in the Tupperware generate a magnetic field upwards. In addition, the battery connects to the safety pins, which in turn connect to the copper wire, making a complete circuit. Using the FBI right-hand rule, we can determine that since the current at the top of the coil is to the right and the magnetic field is up, the magnetic force on the top of the coil is out of the page. However, at the bottom of the coil, the current is to the left and the magnetic field is up, meaning that the magnetic force on the bottom of the coil is into the page. This creates a net torque on the coil, causing it to rotate. Here is a side view of the forces. Unless the coil is horizontal, there will always be some component of the forces that keeps this torque going. When it is horizontal or close to it, the coil can rely on angular momentum to keep it spinning. The end. End.